I've been talking to a lot of people about Windows Azure lately and building quite a bit of stuff in Windows Azure too. And one of the things that struck me is it's actually hard to find one good resource that takes you through the value proposition that is both cloud and Microsoft's implementation of it in Azure. So I thought maybe the best thing to do is use about an hour and see how much stuff I can jam into it and aim for the world's greatest Azure demo. Aim high, I'll see how close I get, but this is going to be a heap of stuff that helps you understand what Azure is and hopefully makes a little bit more sense of this whole cloud thing. So let's just jump into it. And where we're going to start is in the Azure Management Portal. And I'm currently logged into my portal, and this is all of the assets that I currently have in Azure. Let's start making stuff. And to make stuff, everything is very user-driven on demand. You just basically drop into this little new item here and choose what you want. And what I thought we might start with is a virtual machine. And what I want to show you first is that when we look at the gallery for virtual machines, we've got a heap of stuff in here. So lots and lots of different Microsoft products, everything from clearly Windows Server editions through to things like SharePoint, but then all the way through to things like SQL Server. So an actual platform, a product on top of a Windows Server, and then lots of open source and Linuxy stuff and other things that a lot of people probably didn't expect to actually get in a Microsoft product. But it's in there, and we can just go next, 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 all the defaults, and stuff happens. But let's do this. Let's just grab a Windows Server. We're just going to take the latest and greatest we can. Windows Server 2012 R2 Data Center. That is just fine. I'm going to give it a virtual machine name, and I'm just going to call it Greatest VM. We can choose a scale. I'm just going to go with the default at the moment. Single core, 1 3/4 gig of RAM. We'll come back to scale a little bit later on. I'm going to make a username in order for me to log into it. And I'm going to make a password. And we will just confirm that guy. And then we're just going to jump into the next step. I'm going to leave most of this just exactly where it is. The only thing I'll point out for the moment is that we can choose where we want to put this. We can put it in various locations around the world, and there are more coming online later on, like Australia. Hurry up with that one, please, guys. That would be great. Everything else, defaults, defaults, defaults. Let's go through. We can see that it's going to open up a couple of endpoints that I'll talk about in a moment. We can remote desktop and we can PowerShell, but that's about it. Let's just say OK to that. Now what we'll see here is first of all a little message from when I was cleaning up before. It deleted some stuff. We'll get rid of that. Everything else we see here is a very sort of asynchronous single page web app sort of environment where lots of stuff goes away and occurs whilst I'm sitting here talking. What I'm going to do though, because virtual machines do take a little while to create, I mean this is relative terms, 5 minutes, maybe 10 minutes, I'm going to leave that guy creating and I'm going to go off and do something else. And what I want to do next is go and take a look at websites. So let's go and check that out. So let's jump over and have a look at what I've got at present. I've got 2 websites here. One's called Hack Yourself First, and one is called Have I Been Pwned? Now what I could do is jump in and create a new website. I can go and choose something, say, from the gallery. And if I jump into the gallery, I'll find a bunch of stuff that's actually pretty familiar to me. So things like, let's have a look, Acquia Drupal. If I really wanted Acquia Drupal, I could get that from here. Something a bit more familiar to the Microsoft space, the DNN platform. So there's a heap of stuff straight out of the box here. And it just means that I can start a website with all of this already configured. I want to do this a little bit differently though. I'm going to get rid of this wizard. And I'm actually going to go and drag from one of my other screens my Visual Studio open. And I've already got a web application here. And we're going to take a look at what that looks like in just a moment. But what I want to do is use the Server Explorer to drill into my Windows Azure account. And there's those 2 websites I have already. And I'm going to create a new website directly from here. And let's call this guy Greatest Website. Now I'm going to put this in the same region as the VM. In this demo, I'm not actually going to do anything with the 2 of them, but you want to be really cautious that when you create interdependent resources like websites and databases, they're in the same location. Things don't behave real well if you don't do that. So one of the reasons I'm doing this in Visual Studio is I want to show you how there are different ways of coming at Azure, but they ultimately create the same underlying resources. What that means is, if I minimize this, here we go, in my portal, I can now see that I have a website called Greatest Website. Now this is pretty cool because I have actually just created a live website facing the world. It's there, it works. It's been given this temporary URL. And if I click on that guy, we'll see what this website looks like. And you can see the URL just takes the name of the website and puts it on .azurewebsites.net, and here it is. So basic demo website with a standard Azure template. The other thing about this is that there's a wildcard certificate, which means that I can access HTTPS as well. So if I want to test my website over HTTPS, this works just great. Now, of course, this is not really the website I want to stand up. It's just a demo. So let's jump back over to Visual Studio and let's publish my website. That's what I want to look at next. Now, there's a really easy way to publish websites into Azure. And all I'm going to do is just jump over to my Solution Explorer, right-click on the website, grab Publish. I've got another demo that I was doing in there before. I'm going to ignore that. What I'm going to do is just click on Import, Import from Windows Azure, show me the websites I've got. Here's a website. It's called Greatest Website. OK to that. It's going to download the publish profile from Azure, so that gives me things like the server name that it needs to publish to. And I'm just going to go Publish. And what that's going to do is it's going to compile the website locally, and it's going to publish it all up over HTTPS. We can see the path here it's going to publish to. And magic will happen and everything will be live. Now, while that happens, I just want to jump back over to the website for a second and jump back into the management portal and show you what we've actually got here. We can see here under the mode column, it's a free website. My other ones are standard websites. Now let me just be a little bit clear about costs here. Now the cost of a free website, and I think you can probably see where I'm going here. I'm just going to drag the Azure pricing calculator over here. Cost of a free website is, wouldn't you know it, free. Now of course there are limitations on a free website. So for example, I can't bind a domain, and we're going to have a look at how to change that later on. The next tier up is I can go to a shared website. Now when I go shared, I'm in a multi-tenanted environment. The same piece of logical infrastructure is used by multiple tenants. So in other words, other people's websites. The cost as well. When I go to one, $9.77 a month. Now one thing to note with the calculator, make sure you scroll down and check what currency you're working in. I'm working in Aussie dollars, not dissimilar to US dollars. It'll be a little bit less in US dollars. Regardless, under 10 bucks a month for a website, and then you can do things like use custom domains. So tell you what, let's go back into Visual Studio and we'll just check that that website is now live, and it should be just about there. We can see that it is publishing each one of the assets. One thing you'll notice about this process is it's a little bit slow. Now again, this is a relative term. I've just gotten a website up and running and live in the space of a few minutes. But I'm going to show you how to make it a lot faster by deploying from source control in a minute as well. Main thing is for now, this guy says, hey, publish, one succeeded. Let's jump back into the browser, back to our website. We'll give this guy a reload, and what we should see is the live running website. Now, unfortunately, this isn't quite what we see. And I'm not quite sure why it does this, but sometimes it seems that when I publish a brand new site, it goes a little bit nuts. But at least it shows you this is not a contrived demo. Not everything always goes to plan. But what I did want to do is I wanted to take that up to a standard website anyway, because I'm going to want to whack a domain on it later. So let's go into my Greatest Website. And oddly enough, I find that when I scale this, the website actually starts working, or it might have failed before. And within my management portal, I'm just going to go, hey, give me shared, save that guy. And now it's saying, hey, are you really sure you want to do this? Because it might affect your bill. Well, it will affect my bill because it's going to go from $0 to $9 something a month. So I'll say yes to that. And while that's saving, one other little thing. successfully created virtual machine. So that virtual machine we set up in the first step is now created, and we'll come back to that and have a look at it in a moment. Now, for all of the assets in Azure, so things like virtual machines and websites, the billing is per minute. So for argument's sake, if I run this demo for an hour and then I delete these resources, I'm only going to pay for 60 minutes worth of runtime. Now put that in perspective. Back to the pricing calculator. This is how much we're paying for that website. That is 1.4 cents per hour. Now for your entertainment and for everybody's education, I'm happy to pay 1.4 cents for this website. And it's funny how you actually have to wrap your head around how different the prices are in this model. Let's go back to our broken website and give it a reload now that I've scaled it back up. I now have the world's greatest Azure demo running as a standard website, which is good news. So that's great, but this probably isn't the domain I want to run it on. So let's move on to the next thing in this demo, and that's binding a domain name. Okay, so let's move on to that domain bit, because free websites are great and temporary URLs and things get you working very quickly, but really we're not going to stand up anything useful without a domain. So let's jump back over into our management portal. We're now running on shared, and because we're running on shared, it means that when we're going to configure, more stuff works. Now some stuff still doesn't work. So for example, you can only specify a 64-bit system in standard mode, not in shared. Now we'll come back and make this standard later on so we can do some other stuff. Main thing is that as we go down and we get to manage domains, we can now go through and drop in a domain name. Now I have set one up specifically for this demo, and that particular domain is worldsgreatestazuredemo.com. Now before I can actually add a domain to an Azure website, I need to add a CNAME entry. And in fact, I need to add a CNAME entry for the alias AW-verify, and I need to point it here. So I'm going to copy that so I don't get any of this wrong. I'm going to bring over my DNS management environment, and in this case it is GoDaddy, and yes, I am conscious that many people don't like GoDaddy, but it is also extremely common and is the most relevant example I can give you. So we will add AW-verify, and I'll paste in the address that I copied just before, which is this guy just here, awverify.greatestwebsite.azurewebsites.net, and let us now save that zone file. You're about to save it. Okay, I'm sure. Now, of course, the thing about DNS is it can take usually 1 hour up to 48 hours. I do find, however, that with GoDaddy and Azure, it seems to kick in pretty quickly. And we'll see if it works this time or not. But what I should be able to do is grab that URL, copy that onto the clipboard, back to Azure, paste in the domain name, things think, magic hopefully happens, and there we go, green tick. So that means that Azure has been able to identify that change. Last thing I need to do, the IP address to use when you configure A records is this guy just here. So I'm going to copy that back to GoDaddy into my A record, which is just here, paste in that IP address, save the zone file. I'll get the same sort of warning about having to wait for magic to happen. Okay. Back to Azure websites, say okay to that, and if everything has actually worked, it should now be good. We can see here that it's updating, all updated. Let's see if I can grab that address and go to worldsgreatestazuredemo.com. And of course it will think and think and think, and here we go. It now works. We have now got a domain bound. It also means I can kill off that other one on the temporary URL, so we don't need to use that Azure websites address anymore. Get rid of that guy. We're now doing everything via a nice friendly URL. So that is awesome. We've created a free website, we've deployed to it from Visual Studio, we've scaled it up to a shared website, we've bound a domain, and if my math is right, we should be somewhere within about a quarter of an hour into this demo, including all the explanations. So that is good. Let's turn it up a notch and start deploying from source control. Okay, so let's have a look at the situation with source control. To date, all I've done is just publish out of Visual Studio. And that's fine, that's marvelous, it works very quickly, but really you don't want to be deploying production websites from your IDE. It's too error prone, you're sending too much content over the web. What you really want to do is make sure you're pulling everything from source control. So let's do that. Back over to the management portal, I'm going to go to the dashboard and I'm going to scroll down on the right hand side and I'm going to set up deployment from source control. Now when I do this, I get a few different ways that I can deploy. Visual Studio Online, local Git repository, Dropbox. You can actually set up Azure so that you can drop files in your local Dropbox folder, let Dropbox magic happen so things sync, and then Azure will automatically pull that and then push it to your repository. Kind of cool, but today we're going to go down the GitHub path. So what's happening is I have previously authenticated to GitHub and linked things into Azure, and all it's doing now is just going back to GitHub and looking at the repositories that I have available. I've got a whole heap of them in GitHub, and we're only really going to be using the one, and it's not Evil Shoplifting Site, that is another demo. It is going to be another one from this list, and apologies, but I'll have to obfuscate a few things towards the bottom of the list. Clearly, World's Greatest Azure Demo is the one we want, and I put this in GitHub before this demo. When I select it, it's going to want to deploy from master. And what it means is that every time I push something into the master branch in GitHub, Azure is automatically going to pull it out and deploy it. Other people like to use publish branches or deploy branches or things like that, and there are good use cases for that, but today we're going with the defaults. So okay to that. Now we can see a little status here. It was linking. It is now linked. We can dismiss all that. We can now see that there is more magic happening. Your GitHub repository is linked. We can now see deploying. So what's actually happening here is my Azure website is going off to GitHub, pulling it, well, it's already happened before I can explain it, but basically it went off, it pulled everything, and it has now deployed it. Now when I was preparing for this demo, one of the things I actually did is I put the greatest word on that website in emphasis. So that is what is in my GitHub repository. What it means is that this word, when I refresh now, should appear in italics, which of course is what we get from an EM emphasis tag. Okay, so it is now gone italics. Now that's fine. Here's what I want to do though. I'm going to flick back to this tab. I'm going to drag Visual Studio over again. And in fact, if we scroll down, we should see that there is no emphasis on greatest. So this is actually not what is in source control. I removed those EM tags after I last committed it. So let me now go and grab GitHub for Windows and I'll drag it over here. We have an uncommitted change, which is removing those EM tags. I am going to say, whoops, removed EM tag, like so. Let's commit, let's sync. And because we can still see the browser window behind this, what we should see is that immediately after this hits GitHub, Azure should go off, grab that change, pull it, build it, because what you got to remember here is that Azure is actually building the solution. It's not just picking up files and moving it, it's looking for that .sln file and it's compiling it and it's publishing the web app. So here we go, deploying, 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 and it is done. So removed EM tag is now our live version. So let's see if we have indeed had an EM tag removed. Back over to here, let's see if we still have italics after we reload, and we don't. Magic has happened. Greatest is no longer in italics. So that is a really good example of how fast it is to deploy via GitHub, and part of the reason it's so fast is because of all the version control beauty insofar as just the changes have been pulled down to Azure. I just changed one file. That's a pretty small change to pull down into Azure, and because Azure already has a local copy of the repository, it only needed that one file. Now here's the other thing that happens. When we look at my two deployments just here, both of these deployments still exist in Azure. It saves, I think it's about the last 5 deployments. They get saved in Azure. If I drop this little arrow down, we'll actually see a little bit more info about the deployment. So we'll see things like, for example, deployment scripts and the output of deployment commands. Now this was the first one. So this was where the greatest word was in the EM tag. Now here's some of the magic. Let's go and click on redeploy, and we can say, are you really sure that you want to do this? Yes. It will then push out that previous deployment. So because Azure keeps these previous deployments just sitting there ready to go, bang, we're done. No editing there, that's real time. We can go back to our website, reload, and we should get italics again. There we go. Now that is really cool, because that means that if you screw something up, and believe me, I've screwed some of these up before, you can then be out wandering around with your smartphone, open up the browser, and go, give me that last version, and it just deploys out. So that is a really super easy way of managing your websites. All right, so all of that is pretty cool. All of that is websites. And the thing about websites is that it is a platform as a service offering. It is a bundled up service that is much more than just hosting. It's all the stuff that goes with it, such as the on-demand scaling and the ability to simply hook into source control and other things that we'll look at a little bit later on. But you can always just drop back to the metal, back to the raw infrastructure as a service, and set this stuff up manually. Now, I generally don't think that's a good idea unless there are things that you absolutely positively have to do manually, but of course, there are those times. And that brings us back to the virtual machine we created earlier, which is now ready to use. So let's move on to the next section and we'll remote into that machine and start managing it. So let's find that virtual machine we created earlier, and it should be down here in VMs. And here it is, greatest VM. It is running in East US, that's where we put it. Now all I have to do to remote into this guy is click the connect buttons. And what it's going to do is download a .rdp file. Here it is. I'm going to click into that guy, and it is going to put something on a different monitor over the other side because it just seems to like to do that. And we're just going to connect into that guy. And because it also likes to mess with me, it will put the prompt all the way back over on the other screen again, and I'll drag it back over. And I'm going to use another account to connect. And this is just the one we created just before. And I'm going to hopefully remember my password if we want magic to happen the way it should. Okay to that, and it goes back to the very first monitor again, and we drag it back again, and then it goes all the way back to the very first monitor again, and I'll drag that guy back into focus again, and hopefully this will be the last time we do this. One thing to note as well is that if you're doing this within a corporate environment, you may find the default ports for RDP are blocked. So before you beat your head against the wall in the office trying to connect to your shiny new SQL VM, maybe just test it from a connection that doesn't have the sort of firewall restrictions that many environments do. Now, this is going to take a few minutes to fire up because it's the first load of a new machine. So I want to go show you something. I'm going to minimize this guy, and back on the portal here, okay, let's drill into this VM. And one of the things you'll find here, first of all, notice how there's a lot less options than what you have for websites. Because it's not sort of a managed platform as a service where you've got all of these different options around a very specific offering, it's a lot more high level, a lot more generic, fewer things we can configure. But we can configure a couple of things, and one of them is endpoints. Now when I set this machine up right in the start of the demo, I said, look, here's a PowerShell endpoint and a remote desktop endpoint. And really all these endpoints are doing is allowing connections into the environment. Now what I want to do here, just as a demo, is let's imagine we did want to put IIS on this environment. We would want to allow port 80, probably port 443 for SSL as well. Let's just do 80 for the moment. So we're going to add a port. We'll just use the default here. We'll jump in here and we'll call it, what do we want? HTTP port 80. All the other defaults are okay. Go for it. This is now going to allow HTTP connections. Now, depending on the port and the protocol, you may still need to configure the Windows firewall in the machine, but this gives us the ability to make the connection. Now we can see here the whole thing is actually still configuring, adding. What we can do, and we can do it for things like remote desktop that are already there, is we can go down and say, let's manage ACLs. So let's whitelist the IP addresses that are allowed to connect to this. And in this case, it's just asking for a remote subnet. Now, the good thing about this is that if you're always managing your environment from a single IP address or a single gateway or a couple of very known limited sets, you can go through and whitelist this here. Now, it's not a VPN. Don't confuse it with that. You're not going to get any encryption on the connection if it's not implicitly supported by the protocol, but you are going to stop other people from being able to remote into your environment if the IP address isn't whitelisted. Now, note you can also do that with HTTP. So you could actually stand up a website where you say, I'm only going to allow people from a set of whitelisted IP addresses to connect into it. And that is kind of cool. You also can't do that with the website service we just looked at before. So let's close this guy, and I'm going to jump back over into my remote desktop. And with any luck, here we go. We now have a remote desktop. We are remoted into the server. This is just the first run. And again, it's a Windows Server 2012 R2. I'm seeing the local time over on the east coast of the US because that is indeed where the machine is running. And basically, we have an environment. Now, I know I did this right at the start of the demo and then came back to it. But again, you're normally looking at somewhere in the order of 5 or 10 minutes to get a brand new machine set up. No paperwork, no approvals, no book, well, none of the usual rigmarole that you often go through. That has good and bad sides. The main thing is that the facilities are there to do this almost on demand. And whatever governance you decide to put on top of that is another issue, but at least it's not the technology holding you back. So let's look at something else. The promise of cloud is this sort of dynamic scale where you can say, hey, look, this size was good for me yesterday, but it's not good for me today. I just want to change things quickly. Let's have a look at what we've got inside this VM. And I want to just be really, really clear about capacity here. And in this case, let's take a look at, say, RAM. Okay, so we've got 1 3/4 gig of RAM in here. This is what we've got in the processor stakes. That's great. That might be a good starting point. But is it really enough? Well, maybe it's not enough. So let's do this. Let us jump back into the portal. And what I'm going to do is just resize that portal. We'll just give him a little bit more room here because I want to see what happens to that RDP session in the background as we start mucking around with this. I'm going to go into configure. And I'm going to decide that, that's not really enough. I want, hey, let's get 8 cores and 56 gigabytes of RAM. Now I'm going to save this. And if I save this and I scale it, it is going to restart. Okay, that's fine. I'm about to fundamentally change the configuration of it. Now, while that's happening, let's check the pricing calculator. So what would we actually pay if we scale it from that little sort of small instance up to that big A7 instance? Well, here we go, Windows Virtual Machines. So we were at, for one instance, we were at about $67 a month. And again, that's Aussie dollars, a little bit less in US. I want to take it up to this guy, over $1,200 a month. Now that sounds nuts. I'm not going to spend $1,200 just to give you guys a demo. But again, look at this, $1.61.50 an hour. So that's nothing. I don't care about $1.61.50 over an hour, and I particularly don't care about one small fraction of that because I'm only billed by the minute. As soon as I finish this demo, I'm going to either turn this server off and I'm no longer going to be paying for this compute power, or I'll just delete it altogether and I'll still no longer be paying for it. Of course, if I just turn it off, I can always start it up again. And indeed, if you have a look at my virtual machines, and we go back to the list here, I've got this guy. It's stopped. It's deallocated. I'm not actually using it at the moment because I don't need it. I use this for my Have I Been Pwned project in order to import large data breaches, but I only need it maybe once a week or once every other week. So I just start it when I need it. I go and get a coffee while it's booting up. It'll take a few minutes. I come back, I use it, and I shut it down. You can see down here, I can just start it as soon as I want it to fire up again. Getting back to our current demo, here's our greatest VM. it says it's starting. If I go back to my RDP session, we will probably find that it is, well, it's kind of not working. It's dead. The whole thing is actually restarting. So I'm going to flick back again. And actually, there we go. We can see that we have actually disconnected on our RDP session. So I'm just going to cut the video here for a couple of minutes. I'm going to let it reconnect, and then we're going to see what we have back inside our environment. Okay, looks like everything is just woken back up again, which means that I can now jump back over to here and log in again, if I can remember the correct password. Okay, so it's just logging back in again, and again, what we got to remember here is that this is just a normal machine. Well, it's kind of a normal machine. It is an infrastructure as a service machine. So it's a virtual machine that I've been able to just provision on demand. It's sitting on top of shared infrastructure. It does have its own allocated resources, which is why we saw things like 1 3/4 gig before, but for all intents and purposes, it's its own logical machine. Now, I'm not quite sure why in a server it wants to connect to printers and TVs, so we will say no, let's not do that. But let's go and have a look at the scale now. So we'll go back into local server, and what will we see here in our RAM? 56 gigabytes, nice. And of course we now have a different processor as well. And inevitably, if we jump in and say run Task Manager, we should see a whole bunch of processes sitting in there, which would be very, very nice. Over to Performance. And of course, when we jump down and have a look towards the bottom right, we will see that we have 8 virtual processors running on 2 sockets. That is a rather tasty looking little machine. So very happy with that. We have just scaled up on demand to a totally awesome configuration. Now, of course, I can go in and manage this just like any other server. I can go in and add and remove components, including, say, IIS, and build this up as a dedicated web server. I can go into Windows Firewall. I can basically manage any of the normal things that you would on a Windows server. So that is great. What I want to do now, though, is start to have a look at some of the monitoring that we can get from outside of that virtual machine environment. So let's go back and have a look at the portal. Okay, so back on the portal, let's have a look at monitoring. And we'll start by having a look at the machine we just created. So let's jump into this greatest VM and we'll hit the monitor tab. And what we'll see here in this very Ajax-y sort of interface is a whole bunch of metrics for the machine. Now, I've only just recently created this machine, so we don't have a lot of stats, and we're only seeing stats for the last hour. But what you'll see down here is metrics like, say, CPU percentage. So how much of my CPU is being used? Now, this is really handy. If we're seeing that we're consistently using, say, 7.7% of the CPU, do we really need those 8 cores? Do we perhaps need 4 cores? Could we scale this down, and keeping in mind it's got to reboot, but do we perhaps on a Sunday night scale this down to 4 cores, everything's still identical in the machine in terms of the files and the configurations, it's just the virtualized infrastructure that's changing. If we knock this guy down to 4 cores, and let's do a demo. Well, let's rather take a scenario. If we went from 8 cores, 56 gig of RAM, $1,200 a month, and we took it down to, say, an A5, and now we're looking at only 2 cores, 14 gig of RAM, we have just taken out about 3/4 of the cost. Being able to say, I'm going to save $900 by scaling this down, and I know I can probably scale it down because my CPU is only sitting there at under 10%. That is a really nice option to have. Now, maybe the right answer is somewhere in between, and you just incrementally scale it down. But when you have the choice to choose your scale and apply it with such low friction, it gives you a whole bunch of different options you didn't have before. And that's where this monitoring is really good, because it can tell you this information. So on monitoring again, a couple of things here, because we're going to have a look at the website monitoring in a moment. CPU, disk I/O, network I/O, duration 1 hour, we can make it 24, we can make it a week. An increment here, the increment we're seeing is 5-minute increments. 255, 3, 305. Now let's go and have a look at websites. So back up to here. Here's the website we created just before, greatest website. Let's drill into him. Let's look at our monitoring, and we're going to see a couple of different things. Now, one of them is different metrics. Now we're seeing things like HTTP server errors. HTTP server errors are very specific to IIS. They don't necessarily make sense for a Windows Server virtual machine. You may not run any HTTP services on it. We're also seeing things like requests. These are HTTP requests to the underlying web server. The other difference is we're looking at 1 hour here, and again we can do 24 hours, 7 days, but we're seeing increments here of 1 minute. So on a website, your monitoring is broken down into 60-second intervals. What this means is that you can change a website, deploy it out, and immediately see the impact on the environment by virtue of the monitoring. You write a dodgy piece of code and your CPU is probably going to get seriously hit. You inadvertently load up too many other assets on the web page and your requests are going to go right up, assuming the traffic itself is static, of course. But you know, while we're looking at requests, there's another thing we can do here, and this is setting up alerts. So one of the things that I want to know about is when certain events happen to my monitoring. So for example, I genuinely want to know for my websites when the requests start going through the roof because it's probably gotten a bit of press somewhere, or there's been some other event that I probably want to get on top of. So let's do this. Let's add a rule. And I'm going to make this rule website busy. And we'll say something like requests exceeding 100 per minute. Of course, busy is a pretty relative term, so pick whatever you need to there. We'll go on. Requests is already selected. You can't change that because we created the rule whilst the request metric was selected. And we're going to say if the threshold is greater than 500, and it's going to be count, can't change that either, over the last, pick a period. So maybe 5 minutes is too small. You want to know, hey, what if it's really busy over an hour or something? We'll take 5 minutes. Send an email to the service administrator and co-administrators, enable the rule, make it go, and here we go. Creating the rule, this will be done. If this website now suddenly starts getting lots of activity, I'm going to get an email. Now this is neat, and it's just one of the other things you get by virtue of having a website service. Let's move on, and I want to talk about availability and particularly about SLAs. Let me show you an email that I got just recently from Azure. It's this guy just here. And effectively what this says is, dear customer, we're going to have to do some maintenance on your virtual machine. And of course, this is fine. Machines do have to have service packs and patches and security fixes and all the rest of it applied to them. And it is very nice of Microsoft to do this for me in my virtual machine. Now, what this is saying though, is it talks a lot about availability sets. And in fact, this one says, these maintenance operations impact single instance deployments of virtual machines that are not using availability sets. And what it's really saying is that if you only have one server and we've got to take it offline because we've applied some sort of a patch, you subtract one server from one server, you've got 0 servers. If you have an availability set and you have multiple servers and we take one off, you will still have more than one server running. Now this all comes back to SLAs. Most of the services in Azure have a 99.95% SLA. In other words, your service may be offline for up to 0.05% of a month before you get some form of financial compensation. Now 0.05% of a month is about 45 minutes. So you must expect that your service could be offline for 3/4 of an hour. It may not all be together either. And here's the other thing. If you have multiple services and they all have that same SLA, they may not all be offline at the same time. Your website could be down for 45 minutes, and immediately after, your SQL database could be offline for 45, and immediately after that, your table storage could be offline for 45. You could have 2.25 hours of outage, which is actually 99.8% availability, and still be within the SLA. Little bit off topic, I've got a blog post on that if you want to go and look at Azure SLAs. The point here is that if we can use an availability set, Microsoft will give you a 99.99 SLA. Now what that means is that conversely, rather than up to 45 minutes offline per month, it's only 1/5 of that. So think more around 9 minutes. That's a big difference, and it's all to do with availability sets. So let's go and take a look at what an availability set means. We're going to go back to a VM. We'll drill into our greatest VM. We'll drill into configure, and we will look in availability sets, and we will see there is nothing there. We can create an availability set, and we will obviously call it greatest something, greatest availability, which it doesn't like, so we go backwards and backwards and backwards and backwards until it does like it, and we say save. Now this is going to create an availability set once I hit the button correctly. Yes, we want to do that. And it's going to think, and it's going to give us a warning in just a moment which says, hey, you have an availability set, so that's fantastic, that's really good, but you only have one machine in there. Now what Azure wants you to do is to have multiple machines, 2, 3, 4, keep going. When you have multiple machines in the same availability set, what happens is that Azure makes sure that when maintenance is performed, you don't have them all offline at once. Here's that message. So Microsoft have actually got a good little diagram which sort of shows how, look, you might have one server in an availability set in one rack on one side of the data center, and then there's another one somewhere else, so that really if you sort of go through logically, you're not taking them all offline at once when you get emails like the one I just showed you before. Now when you go and add more machines and you put them in the same availability set, that's when warnings like this go away. It is still up to you to manage how traffic is routed to those machines when they may go offline. And this is why we have things like Traffic Manager in Azure as well, which I'm not going to talk about in this demo, but be conscious that it's there. So that's availability sets, and now you're aware of what the SLAs mean and how they relate to actually having machines online and giving yourself a bit of redundancy against simple outages. I want to have a look at one more thing in virtual machines before we go and take a look at some other things. So here's what I want to look at next. I want to look at disks. And I want to look at disks just because it's a good example of something that in the offline world, in the traditional world, has often been a little bit tricky. A little bit tricky insofar as the process of requesting storage and the associated cost. Let's have a look at what it means in Azure. Let's imagine we want more storage. We've got the VM selected. We say attach. I'd like to attach an empty disk. And I'm simply going to say OK. Now, while that is attaching, what does a disk cost? Pricing calculator. I often find it's easier just to go full calculator and search for storage. And we will find it down here. Now, a couple of things here. First of all, we're talking about locally redundant storage. And what this means is that all of your data has 3 separate copies. It's all in the one data center. It's all one seamless instance to you, but Microsoft are making sure there are 3 redundant copies so that if any one gets taken out, you've got another 2. If 2 get taken out, you've got another 1. If 3 get taken out, we're going to talk about geo-redundant storage in just a moment. Let's have a look at how much storage costs. Now, here's the problem I have with the calculator. It's very, very hard to select small numbers. About as low as I can get this, let's try and get it around a terabyte. That's probably about as close as we can get it. So just under a terabyte, 67 Aussie bucks a month. So let me say that again to make it really clear, because some people seem to think storage is a lot more expensive than what it needs to be. $67 per month per 950 gigabytes of locally redundant triple replicated storage. That is a rather good deal. Now here's the other thing, geo-redundant storage. Let's see if we can get about the same selection here, somewhere up a little bit. There we go, 950 gig. That is almost half as much again. Now why is this? Here's the thing with locally redundant storage. You do not have a Godzilla immunity with your locally redundant storage. Any monstrous forces of nature which take out the data center are going to take out all three of your replicated locally redundant instances. If you're happy to pay that premium, geo-redundant will also replicate your data to another data center in the same region. Godzilla comes along, smashes up data center A, data center B has still got a copy of it. We're getting a little bit off track though. The whole idea here was to add a disk. And in fact, if we now look at the disks tab, we should see that we've got a new disk. This is the one we just created, which is in addition to the existing disk. Now, here's what I want to do. Let's jump back into a virtual machine and let's now jump into disk management. Create and format hard disk partitions. That is the right guy. And again, none of this is specific to Azure. This is just your classic disk management in Windows Server. Disk 2, let's just go OK to all of that. I am by no means a server administrator, and I'm sure there are people who understand this significantly better than me, but even I know how to go through and just simply add a new disk into a Windows server. And most of it is by going next, next, yes, thank you very much, please, perform quick format, finish, and in a couple of minutes we will have just a fraction under 1 terabyte worth of extra disk. And it will be in here. Do I want to format drive E? Yes, please. It is formatting. In a few minutes, we will have another brand new disk. Here we go. Not even a few minutes. Volume E, healthy partition, primary partition. Open up Windows Explorer again. And here we have it. It's just about all free. It is a fraction under 1 terabyte, new drive E. Dead, dead, dead simple. So that's how easy it is just to add additional disk capacity. And of course we can add many more disks. We might not be able to make them a terabyte or greater, but we can add a heap of them. What I'd like to do now is jump back into websites. And what I want to show you is scale, auto scale. And this is profoundly cool. So I'm going to jump back over to my site, greatest website. And if you recall, our scale is shared. So it's actually using resources on the same machine as other websites that may not be your own. Now here's the trick. If I go to standard and I put just this website, Greatest Azure website, on standard, you can see what I now have down here is I have an instance size. If I go back to shared, that's gone. Back to standard, instance size. These instance sizes are consistent with the instance sizes we saw before for VMs. Some of them anyway, small, medium, large. Now what this actually means is that when we go standard with the website, we're actually getting a dedicated virtual machine. We can't RDP into it. We can't open up ports. We can't install arbitrary software. And frankly, I couldn't be happier. I have a blog post around with Great Azure VM comes great responsibility, where I outline what I mean by that. But in short, having a virtual machine gives you a lot of responsibility, and it removes a lot of features that you get around websites such as the one I'm about to show you. Now there's one other thing I want to show you here. Small VM. I'm going to go back to the pricing calculator. I'm going to go back to websites. And if I grab a standard website, I want you to read this. Load balance up to 500 websites per region dedicated to your apps. Up to 500 websites. How much is that? $75. This is one of the points Scott Hanselman makes a lot. For that $75, you are getting one machine that will give you 500 sites. You still pay for storage on top of that, and we saw that cost before. It was $60 something for about a terabyte. You still pay for bandwidth. And bandwidth, two things with bandwidth. First of all, first 5 gig of outbound data is free, so you get 5 gig out without paying. Second of all, you don't pay for ingress. You send data to your site, you don't pay for it. Thirdly, here's what data costs. Let's make it a nice round number, around the 100 gig mark. Around the 100 gig mark, $11 something for 100 gigabytes of egress data. Get smart and use things like CDNs, bundle and minify your assets on the website like CSS and JavaScript, and be efficient with your assets, and 100 gigabytes goes a very long way. Trust me, I've tried. So go back to websites. Now here's what we're getting. Once we go to a standard website, I can put another $499 on here and not pay a cent more other than for whatever storage or egress data they use, or other services that cost money, like adding SSL. But I can get 500 websites and 500 domains, or more actually, because you can have multiple domains per site, for that 75 odd bucks a month. So that's great. But here's the other thing we get, and this is what I really wanted to show you here. What we can do now is we can start playing with capacity and scale. Now before with the VM, we added scale. And what we did is we went from 1 processor and 1 3/4 gig of RAM up to 8 processors and 54 gig of RAM. We scaled up. Still 1 instance, everything more chunky. This is going to allow us to scale out. Let me show you what I mean. First thing we can do is set up a schedule for when we want to scale. There's no schedule at the moment, but we could go through and say, I want to scale differently at night and differently at weekends and this on that time and all of this fancy stuff about when you do or do not want to scale. I'm not going to change any of this, because if my website needs to scale, and we're going to have a look at what I mean by needs in just a moment, I want it to scale. Now here's what I'm going to do. I'm going to scale by CPU. And this gives us these options down here. I'm going to scale from a minimum of 1 instance up to a maximum of 3 instances. I'm capping my potential cost. What this means is, depending on the traffic, I could end up with 3 separate small VMs running my websites, and then everything would get load balanced. Now the way it's going to scale is there is a target CPU range between 60 and 80%. All of this is configurable. Okay, I can find the sweet spot for me. So assuming I leave it at the default and we go from 60 to 80, what it means is that if the CPU of the machine, and we know how to look at that now because we saw the monitor tab before, if it goes above 80, I'm going to get another instance. Now when I have 2 instances, my average is going to come down beneath 80. If that average then goes up above 80 again, I'm going to get a 3rd instance, and I can take this up as high as I can financially tolerate. If I think my site's going to do fantastic things and there's a monetary value to that, I probably want to set this pretty high. If I'm worried about just getting DDoS'd, I'm probably going to scale this down. And incidentally, Azure does have a number of DDoS defenses, but I'm getting off topic. Now, when it goes the other way, so when the CPU gets down under 60%, I'll put that back at 60, it's going to take an instance away. That might bring it down to 2. So now I've only got 2 machines serving the load, so the average CPU goes back up, the load backs off again, it drops down beneath 60, and another instance gets taken away. What I love about this is that it incentivizes you to use a small instance size, but to have lots of range in terms of the number of instances you have. Because when you do that, you are only going to be provisioned and then charged for resources that you need. I hate the idea of this classic model where someone says, 3 years from now, your website is going to grow big enough that you will need a gajillion gigabytes and 20 million CPUs, and therefore you're going to have that now. You don't need it, and you will pay for it, but we speculate that sometime in the future you may. Or conversely, someone underestimates. You get 6 months, 12 months down the line, and you've got a serious scale problem. So you've saved yourself money early, that's good, but now you've got a technical debt by virtue of underestimating. This model gives you what you need when you need it, both more or less, and you only pay for it then. That is freaking awesome. Now, as awesome as that is, I want to move on and show you something else. And what I want to show you this time is something around auto provisioning. So remember earlier on, right back at the start, I created a VM in the management portal here, and then I showed you how we could create a website in the management portal, and then I said, but I'm going to go into Visual Studio, and I'm going to provision it out of Visual Studio instead. And that's what I did. And the point I was making is that you can provision resources through multiple different interfaces. Indeed, there are APIs to be able to do that. RESTful APIs, because they're all the rage. But there is also a set of Azure management libraries. Brady Gaster on the Windows Azure team talks a lot about these, and he has some great material that I've used to create a little demo. Now here's what I want to show you in my demo. I'm going to go and list all my resources. And actually, while I do that, you can see this message here says, hey, I haven't saved my changes, which is kind of handy because it's easy to lose track of what you're doing when you can configure so much online. So let's just actually cancel that, save these changes, because I do kind of like the idea of auto scaling. And yes, I know that there's a financial impact, but I'm only going to pay for it if I need to. Show me all my resources. Now what I'm going to do is over in another window here, I have my Visual Studio running that's got about 100 lines of code, mostly plagiarized from Brady, that is going to automatically provision some resources. I'm going to run this project and I'm going to drag over the little console window. And I want to explain what's happening on here. So the first thing it's doing is it's going out and it's looking for an instance of a virtual machine that is called SQL Server 2012 SP1 Standard on Windows Server 2012. You can provision a pre-built SQL Server instance on Windows Azure. In fact, if we have a look at the pricing calculator and we have a look at our virtual machines, what you'll see here is that there is a pre-built SQL one, and that pre-built SQL one, just down here, if we take, say, a small one, and we take, say, one instance, we're going to pay $101 a month. That actually sounds a little bit more than what we're paying for our standard VM before, the Windows VM. If that was small, with one, it was only 67. The difference is, not only do you have SQL Server installed on this instance, it's licensed. You don't have to go out and pay large amounts of money for the license, either for standard or for enterprise up front. You can lease the entire environment, a little turnkey solution, if you like. But don't let me lose track of this little console here. Okay, so what my little console here is doing is it's gone away and it's found that SQL Server image and it's found the ID for it. So we actually need to get back an internal name for it. It's then gone away and created a cloud service, which is like the umbrella under which our VM sits. It's created a storage account called the Greatest Azure Storage, and inside that storage account, it's going to put the VHD, the disk. And we're going to go and take a look at that in just a moment too. So it's created that storage account, and now what it's doing is it's creating the VM, and that VM is going to be Greatest Azure VM. And okay, so we've actually seen the whole thing just finish. So it's taken 121 seconds, but what we've actually got now, if we go back into our portal, is we're going to have a VM called Greatest Auto VM. Let's go and see if he's there. Let's go into virtual machines. And sometimes I find you've got to give it a reload after auto provisioning stuff. It's almost like the portal keeps track of things that you're creating and auto refreshes those. But if you do something in the background, sometimes it tends to get a little bit lost. The main thing is that they all end up in the same place under the same subscription. This just gives us a way of orchestrating the process. And I really like the idea of orchestrating, say, non-production environments. So what happens if I just want to build a test environment from scratch? I could just put it in a console app, fire it up, magic would happen, and it would all be there. So now we can see here is our greatest Azure VM. And you can see it starting up. It's all been provisioned, but now it's actually powering it on and it's running for the first time. I won't bother emoting into that because you've seen what that looks like now. The main thing is that we've seen that we've been able to actually automatically provision the resource. Now before I move on, I mentioned VHD and the disk a couple of times. If you've created virtual machines before, even just on your desktop, you've probably seen VHDs. And what I want to show you is that if we jump on over to the storage account, and we can actually go into our greatest Azure storage, which is just here. We can go into a container, and this will be the container that I've just automatically created. And a container is simply going to hold our VHD. So we'll see we've got one here called VHDs. I can go in and this will show me that virtual disk that was just automatically created. 127 gigabytes, so that's the size that's been automatically provisioned. I can now just download that guy. Now, if I try to download 127 gigabytes over my connection, it's not exactly going to be fast, and you can see that we are unfortunately looking at some number of days here. Internet connections in Australia are not the fastest of things, certainly not for 127 gig. So clearly I am not going to be doing that. The point I wanted to make is that you can pull down a VHD. You can also upload a VHD from your on-premise environment and mount it into a virtual machine. So there's some nice interoperability there. Another point I'll make now with regards to storage, and I probably should have made this before when we created a terabyte worth of extra disk. This says 127 gig, but that is the maximum size of the disk. You only pay for the amount of that you're using. When I created a terabyte before, I wasn't paying for a terabyte. I was paying for 0. Now that's a really interesting analogy when you think about the classic on-premise management of infrastructure. If you go to your IT group and you ask for a terabyte of disk, chances are you're going to pay for a terabyte of disk. If you go to Azure and you ask for a terabyte of disk, you're going to pay for the slice of that terabyte that you're using. And it's probably not going to be 1 terabyte from day one. It may not ever be 1 terabyte. You will only pay for what you use as you go along. And that is a very good example of a commoditized pricing model. So back over to my virtual machines. This is still firing up, but I think I can now stick a fork in this section and call it done because that is the automatic provisioning of the machine. Now just think for a moment what it means when you have a set of management libraries that can automatically create, scale, shut down and destroy resources. For example, might you automatically schedule resources to be shut down on the weekend? If you can shut them down on the weekend and for most of the night, you could cut your infrastructure bill in half. Now that won't work for a lot of resources like for publicly facing websites, but that may work very well for corporate resources used by office-bound colleagues. It at least allows you to have a discussion that you couldn't have before. So that discussion is, hey guys, what's it worth to run this on Saturdays and Sundays and overnight? Is it worth another 20 grand a year? Or why don't you meet them halfway? Hey guys, what's it worth to have this running just as fast on Saturdays and Sundays as it does throughout the rest of the week? If we could scale this guy down to a fraction of the weekday scale over Saturdays and Sundays and just wear that sort of 5 minutes of outage on, say, a Friday night and then on a Sunday night, we could save you $5,000 a year. Now, we as the computer guys don't have to make that decision, but it allows us to have a very, very interesting discussion with our customers that they've probably never had before. That is very cool. So let's look at one more thing that I think is very cool, and that is SQL Azure. Now we've looked at 2 primary types of resource in this demo. We've looked at infrastructure as a service, so that's what we're looking at now, VMs, and we've looked at platform as a service. So that was the website. And it was the website insofar as we got a little slice of IIS, and we either got a free slice of IIS, or we got a shared slice that had other customers on it as well, or we got a slice of our own dedicated VM when we had a standard website. But the other thing that we can get here in Windows Azure is we can get SQL as a service. Now, I'm a developer and I've used SQL day in and day out for a very long time. But I'll be honest, it scares me. SQL Server is a big thing. And whilst, like many other people, I've been the accidental DBA before, I really don't like the responsibility. So let me show you what it means to get SQL as a platform service in Windows Azure. Now, there's a couple of ways we can do that. I can either go down into the old new item in here, Data Services, SQL Database, and I can go and create things using the wizard. Or I can be a bit more contextual about it. Let me show you what I mean. If I go into Websites, and I go into my greatest website, one of the things I can do in here is jump over to my dashboard, and I can scroll down a little bit and a little bit further, and I can manage linked resources. Now, by linking resources, we're going to get some nice features by virtue of an explicit association between them. Let's link a resource, create a new one, we'll make it SQL. It's actually defaulting the name to greatest website _DB, and it's probably a reasonable expectation that if I'm creating a linked SQL database to this website, that it's going to be a part of this website, and hence it's giving it the name. I can choose an existing SQL server that I've created. Now, here's what I mentioned earlier on. Don't use East Asia if your website is in East US. That's a long way between those two places. And likewise, I don't even want to use West US. That's a long way to East US. Not when you really want to get latency measured in a fraction of a second. Let's create a new database server. I'll give it a logon, and we'll just call it Troy Hunt, just for simplicity. I'm going to keep using the same password over and over again. And friends, do not use the same password over and over again. Not for the same service, and definitely not for different services. Auto-generate it, put it in a password manager. Now, clearly the obvious, sensible thing to do here is to make sure I am using East US. It's defaulted to East US to save me from myself. Tick to that. Now it is creating the linked resource. So we are going to get SQL Server as a service, or rather we're getting a SQL Server database as a service. And we can see down here that the guy is still creating. We can see the details of the guy who is still creating. And whilst I have heard some criticism of this interface, so for example, it would actually be kind of nice to be able to scroll through these a little bit easier, but regardless, I actually think it is a very good interface. So now here's what we've got. We're in our greatest website, but here is our linked resource, our greatest website database. Now, we've drilled down into database. So here's what I want to show you now. I would like to connect to this database using SQL Server Management Studio. That is the address of this database. Let's try this. Let's bring over SQL Server Management Studio. Now let's make a new connection. And I'm just going to type the name of that. The authentication is going to be SQL Authentication. The login is going to be Troy Hunt. The password is going to be the same stupid password that I am using everywhere for the purposes of this demo, and it is not going to work, which it will tell you in just a moment. Now the question is, why is it not going to work? And here is a message that tells you. I will obfuscate my IP address, but you should be able to see enough from this message to tell that my IP is not allowed to access it. Now there's a couple of interesting things about this. First of all, my IP can't access it. That's obvious. I need to whitelist my IP. But second of all, SQL Server Management Studio 2012 is aware that my IP address can't access the server, and that there is such a thing as going into the Windows Azure Management Portal and getting access to it. So SSMS is becoming more aware of the paradigms within Windows Azure, or in this case, within SQL Azure. And by the way, you probably keep hearing me call it SQL Azure and not SQL Server. And indeed, Microsoft do call it different things. And in fact, I think the SQL Azure name has changed a couple of times as well. But there are some idiosyncrasies between SQL Server proper and SQL Azure, and we'll touch on those a little bit later. Regardless, I need to set up Windows Azure firewall rules for this IP, because until I do this, I'm not going to get in. The current IP address, blah, 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 is not included in the existing firewall rules. Do you want to allow it? Yes, please. Let me in. Okay, that would be fantastic. It's just going to save that. Now I can go back to SSMS, and now I should be able to connect successfully. So this is good. And what you've got to remember is that if you go between different locations, or if you have a dynamic IP address, which would make life a little bit miserable actually, you may need to add multiple IP addresses into the firewall rules. That's important. If you forget that, stuff will fail and you will wonder why it has failed. Now, what you don't have to do is whitelist the IP address of the website if it is running in Azure. And we'll take a look at that in a bit more detail in just a moment. So here's an interesting thing as well. In SSMS, you're seeing a little blue database down here. So SSMS, again, is aware of what this beast called SQL Azure is, and it's actually identifying attributes of it that are different to SQL Server proper. My PC has SQL Server proper on it. Yellow database, a little bit different. Okay, so we've actually connected successfully, and what we'll see when we have a look in databases as soon as it allows me to, and thank you Australian latency all the way to the east coast of the US for making this a little bit slow. But what we'll see is that I have a master database, so very similar deal to what you'd get in SQL Server proper, and you will see that I have a new custom database. So we'll just open that guy up, and we'll have a look at our system databases. We will have a master, and indeed we can see master is the context of the current database. Now I want to show you one little thing to demonstrate the differences between SQL Server proper and SQL Azure. Does this look like a reasonable statement? Well, of course it does. Let's run it. Okay, so use statement is not supported to switch between databases. This is a very minor difference, but it's a good example of just one of the little idiosyncrasies that occurs between SQL Server proper and SQL Azure. Other idiosyncrasies that have got more significance are things like primary key structure. Some of these will bring you undone if you're not aware of them. But at least in my experience, about 90% of what we would normally know of SQL Server functions identically in SQL Azure. So let's just look at one more thing that we get from making this a linked resource. And here's what it is. If I go back to the website and I go into our greatest website demo and I go into configure, and then I scroll down a little bit, once this guy loads, we're going to see a bunch of configuration settings. Now these configuration settings include connection strings. Here we go. Our connection string has automatically been populated with greatest website DB. The connection string is hidden for security purposes, but we can show it, and we can see our server name here, and ultimately we can see the credentials off the back end of it. And there is my fantastically secure password. Now, why is this a good thing? Well, it's a good thing because it means that when we publish the website, if I have a connection string called greatest website underscore DB, and indeed I can either change this value or I can change the value in my app, this connection string will be automatically applied. So I don't need to store these credentials in source control. Don't put your connection strings in source control, people. Many people have come undone as a result of doing that. I can also do that with app settings. I can have a key in my app setting, just like so, and I can set the value in here and it will overwrite the value of the one on the website. It's almost like a config transform for the release configuration. And this will overwrite any config transforms you have in your release configuration as well, because this happens downstream of that. So that's pretty neat. Now there's one more thing I want to show you in this world's greatest Azure demo, and that is I want to talk about data backups. Earlier on, I talked about locally redundant storage, 3 copies, and geo-redundant storage, and about how your data can be replicated into multiple instances so that if there's failure, you can recover it. Now here's the problem. You are protected from failure, but you are not protected from yourself. If you delete data out of those tables, and if you haven't done this in your career, either you haven't been doing it long enough or you will do it, because I have certainly destroyed data before. And the problem is that when you destroy data and you have locally or geo-redundant storage, you're going to destroy every copy. Now this is where we talk about backups. And it's not backups to protect you from the infrastructure failing. You get that implicitly. You get protection from the local failures. You get protection from the Godzilla scenario. You don't get protection from yourself. So backups are meant to take snapshots of your data over time so that when you screw it up, you can roll back. Let's go to our database. We'll say OK, and we'll just lose those changes on that website. We don't mind that at all this time. And here's what I'm going to do. I'm going to go into Configure on my database, and I'm going to set up an export status. Let's make it automatic. Now what I'm going to do is I'm going to export to a storage account. Now I actually have a storage account that I created when I automatically created the virtual machine from my console app before. And what I'm going to do is every single day I'm going to back it up. Now we get a pink exclamation mark. I'm not quite sure why it's pink, but clearly it is important. Frequent exports can increase your database cost by up to 100%. Now why is this? Well, the reason is this. Microsoft have configured SQL Azure so that when a backup is taken, it actually creates an exact copy of the database, and then it backs up the copy. Now again, I'm not a DBA, but I would fairly assume that that is so that there is no undue overhead on the live database. That bit I'm fine with. The problem and the 100% bit comes from the fact that when that process runs, even though the backup may run extremely quickly, you are charged for 1 full day of the replicated database. Now that's a bit unfortunate because that does double your cost if you're backing up every night. But of course you may not need to back up every night. And this is going to depend on the profile of the app. For example, if you have an app that's not actively accruing data on a daily basis, so perhaps it's a fairly static site, you might say, well look, let's back up once a week, maybe every 3 days, I don't know, find a sweet spot. That could be different to if you are actively collecting customer records hour by hour, minute by minute. You want to have a little bit more redundancy than perhaps losing a week's worth of data. But again, at the end of the day, this is cheap. Until you get to large volumes of data, the cost is literally measured in the singles of dollars per month. It's not very much. So let's leave it there. Every 1 day. Let's use the defaults here. Let's start it at midnight, and let's retain the data for 30 days. So what that means is I'm going to have a rolling 30 days worth of files, and because we're doing it every 1 day, it's going to be 30 files that I can restore to. I'm going to log in as my account, and my password is this. And we all know now that's Greatest Demo 2014. It's going to think about that for a moment and make sure it's right. We get green ticks when things work, which is good, and save. So now what's going to happen is that every single night it's going to automatically back up that data and it's going to appear in my storage account. Now I'm not going to have a backup until this first runs, but let me go and show you one I prepared earlier. I want to show you my Have I Been Pwned website because I have got that set up to automatically back up every night. Now when I go into my containers, I've got one called Automatic SQL Export. Azure creates this for you automatically. And when we look at this, you can see that I have decided to keep a rolling 14 days worth of data. Here's the oldest one, and it gets newer and newer and newer as we go down. And indeed, the data gets larger. I've got people subscribing. I've got various things that are logged. Here's what happens with my data. I can grab any one of these, and I can download a backpack file, a .bac PAC file, just like that. I can then pull this into SQL Management Studio and restore it locally, and it works just beautifully in my local instance of SQL Server. Likewise, I can tell SQL Server Management Studio 2012 to connect directly to this storage account and pull one of these backpacks directly into my local SQL Server instance. So there are lots of ways of us actually working with this data, and indeed I could use the process I just explained to restore it back into Azure if I do screw up and delete things. Now this is really, really important. Don't forget, when you're standing up any website that accumulates data, to have versioned copies of that data. And in fact, one feature that dropped just the week before writing this is the ability to do that with a website as well. It's over here, backups. So if your website is accumulating data, you can actually back it up just the same way that you would with your SQL database. And in fact, you can see it looks pretty familiar. The other thing you can do in here, and I'm yet to use this, is you can actually orchestrate the database backup too. Very neat stuff. So that's where I'd like to leave this demo. And I know it's actually ended up at a little bit more than an hour, but I thought it was really worthwhile showing you the bits that I think are the most fundamentally important. Now this is far from exhaustive, and all you got to do is look down the side of this portal here to see how much other stuff there is in the portal that I've never even touched on. But in terms of helping people quickly understand the value proposition of concepts that they're probably pretty familiar with already, but just haven't seen them in a true cloud context, the one where stuff happens on demand, where you're paying by the minute, where terabytes of data cost amounts of money represented in tens of dollars a month. That's the stuff I really wanted to get through. And more than anything, to show you that once you understand how to tie the pieces together in Azure, you can do amazing things. The biggest thing for me has been learning about how all of these pieces work together and how to use this environment efficiently. And I must admit, it's been an absolutely fantastic experience. So for those of you that are looking at getting into Azure, just get in there and give it a go. Spend a few dollars, literally just a few dollars, to see how the thing works and experience it firsthand. Because I'll tell you one thing, those who don't understand these cloud paradigms and insist on doing things the way we've done them for the decades before now are going to get left behind. This is how we're going to manage our technology solutions, not only in the future, but right now.